Good afternoon. I am going to go over section 7b. So chapter 7, section B. And this is about the types of chemical reactions. The questions we hope to answer at the end of this lesson. First, are all chemical reactions the same? The answer is no, and I'll explain why. How can I tell one kind of chemical reaction from another? And what is combustion? All right, so what are the different kinds of chemical reactions? First, we have a synthesis reaction or a combination reaction, where you have two simple reactants, maybe change this to reactants in your mind, two simple reactants combined to make a single more complex compound. So two simple reactants form one complex compound, okay? Two simple, one complex, right? So they're combining. An example of this would be sodium chloride. You have sodium and chlorine that react to form sodium chloride. And I want you to remember, that your reactants can be individual atoms like this, or they could be, technically that chlorine is Cl2 because it's diatomic, or they could be more complex molecules like water. All right, water can interact with different types of metals or salts to form more complex compounds. Okay, so it doesn't have to just be an individual atom. It can be a diatomic element. It could be a different molecule. But just know that when it combines with something else, it becomes more complex. A decomposition reaction is the exact opposite of a synthesis reaction. So a decomposition chemical reaction is one in which a single compound, more complex compound, breaks down into two or more simpler products. You could have two or three or four simpler products. So you have a single compound that breaks down into many simpler products, as long as it's more than two. And this is the exact opposite of a synthesis reaction. An example of this would be hydrogen peroxide that breaks down into water and oxygen. So you have something complex that breaks down into two simple substances or simple products. And this could break down even further if you wanted to break down this water. It could break down into diatomic hydrogen, diatomic oxygen. A single displacement reaction is also known as a replacement reaction. It occurs when one pure element in a compound is replaced by or switches places with another element in a compound. Okay, so see how this pink pentagon switched places with the red triangle in this example. So think of these as elements that are bound to, this for instance is in a compound with another element. So it switches places, these two switch places, and now this red triangle is the pure element, and the pink one is the one that's in that's formed a bond with this purple element, this purple polygon. All right, so again, you can explain this with letters too. So A and B are bonded together and C is your pure element. But now after the reaction, A has bonded to C and B is your pure element. An example of this would be water combining with pure potassium to form potassium hydroxide and diatomic oxygen. So in this case, oxygen is bonded to hydrogen, but then after the reaction, the hydrogen is your pure element and the potassium is bonded to this, which is hydroxide. A double displacement reaction, notice the charges up here. So I want you to think about this as ions that are switching places. So a double displacement chemical reaction or a replacement reaction occurs when the ions of two compounds switch places. So see here, you've got this light blue cation bonded to the dark teal anion, and in the products, this dark teal anion is bonded to this orange hexagon atom, this hexagon cation, whereas in the reactants, so basically they just switch places. Positive switch places or the negative switch places, however you want to think about it. So in this case, A was bonded to B, but now A is bonded to D. You get the picture. So that's a double displacement reaction. An example of this would be sodium chloride combining with silver fluoride to create sodium fluoride and silver chloride. Combustion is an exothermic chemical reaction. So we'll talk about what exothermic means next chapter or next section. It's a chemical reaction that releases energy, okay, where your products have less energy than your reactants. So the reactant, the fuel, combines with oxygen, and it often produces large amounts of heat and light. So fire and explosions are always combustion reactions. Anytime you see fire or huge amounts of energy or release or light that are released, that's most likely a combustion reaction. It occurs when a compound containing carbon, this is very simplified, right? When a compound containing carbon and hydrogen reacts with oxygen to create, these are always going to be your products of a combustion reaction: carbon dioxide, water vapor, and heat, okay? So carbon dioxide, I want you to think about a campfire. What happens around a campfire? Well, the wood burns and it forms soot. So there's other products in addition, but a combustion reaction always creates carbon dioxide, water vapor, and heat. Okay, so obviously getting heat and the energy in the form of heat and light. You have water vapor that's released from the reaction, and then you also have carbon dioxide that's released from the reaction. All right, an example of this would be methane that is combusted. So CH4 is methane, and it reacts with diatomic oxygen to form carbon dioxide and water. There's a visual for you. So here you have CH4, and these particles hit each other, and they rearrange into water and carbon dioxide, as well as energy in the form of heat. So when methane combusts, it creates heat or fire. So what are oxidation and reduction? These are terms that are new to you, but the concepts behind them are not new to you. So when you see oxidation and reduction, I want you to think about the losing or gaining of electrons. So this is a picture of a piece of iron that has been oxidized over time. Oxidized meaning that it has it has lost electrons in a very slow chemical reaction. So oxidation refers to a loss of electrons in a chemical reaction. Okay, we've heard about this because when an atom loses electrons, it becomes a cation. Okay, it becomes positively charged. And the opposite of oxidation is reduction. When a element gains when an element gains electrons, so that is reduction. These two things go hand in hand, so we often call them redox reactions. Okay, oxidation, reduction are related, so we call them redox reactions. An example of this would be mercury. When it becomes oxidized, it gains, the mercury is oxidized, it loses electrons, goodness, and the oxygen is reduced because it gains electrons. Okay, so this forms a cation because it loses electrons, it loses negative charge, and the oxygen gains the negative charge, so it becomes an anion. And now these two are electrostatically attracted to each other because they have charges that are equal and opposite, so they are electrostatically attracted to each other and will form an ionic bond. All right, and that is it for this section. It's pretty simple. I will be posting another video about section 7C, hopefully later today.